Welcome to my application. In this video, I will highlight what this application can do for you. Calculating the size of stem, heel, toe, and key thickness, and do verification for shear and moment. Bearing capacity verification. Graphic plot for moment and shear diagrams, required flexural reinforcement, nominal moment, stress diagrams, neutral axis diagrams, cutoff location and tension side, and reinforcement distribution. Stability analysis for overturning, sliding, and bearing. Create a DXF file containing the reinforcement details. Create a comprehensive calculation report containing all calculation details. Here, you will find all your projects. Define the size of rebars to be used. In this section, you have to provide the height of wall and the preliminary sizes for heel, toe, key, and base. Then, the application will provide the proper size to be used. This section will cover the characteristic of soil. The angle of internal friction, denoted as phi, used to describe the shear strength and behavior of granular materials. It represents the maximum angle at which a material can be sheared before it starts to undergo internal deformation or failure. To understand the concept better, let's consider a stack of granular particles. When an external force is applied to the stack, the particles will start to rearrange and slide past each other. The angle at which this sliding begins to occur is the angle of internal friction. Materials with rougher particle surfaces or a wider particle size distribution tend to have higher angles of internal friction. There are several common methods used to measure the angle of internal friction, including the direct shear test and the triaxial shear test. Triaxial shear test. In this test, a cylindrical soil sample is confined within a rubber membrane or a pressure chamber. The sample is subjected to an axial load. An additional confining pressure is applied radially. Shear stresses are then applied to the sample along a predetermined plane. By measuring the axial and radial stresses and deformations, the angle of internal friction can be determined using specialized equations and analysis methods. Direct shear test. In this test, a soil sample is placed in a shear box apparatus, and a normal load is applied vertically to the sample. Then, a horizontal force is gradually applied to shear the sample along a predetermined plane. By gradually increasing the horizontal force, and measuring the corresponding shear stress and shear strain, the angle of internal friction can be determined from the shear stress-shear strain relationship. The friction coefficient of soil. It is a measure of the resistance sliding between soil particles, or between soil and other surfaces. It quantifies the frictional interactions and shear strength characteristics of soil. The friction coefficient of soil can vary depending on several factors, including the type of soil, moisture content, density, particle shape, and particle size distribution. Different types of soil, such as clay, silt, sand, or gravel, can exhibit different friction coefficients. Dry density. It refers to the density of soil when it is completely dry or without any moisture content. Dry density is an important parameter used in geotechnical engineering for determining the compaction characteristics of soil and estimating its load-bearing capacity. Saturated density. It refers to the density of soil when it is completely saturated or filled with water. This occurs when all the void spaces between soil particles are occupied by water. The saturated density of soil is typically higher than its dry density because water has a higher density than air. This section will provide the characteristic of concrete and reinforcement. Sliding factor. Overturning factor. Shear mobilization factor. The strength mobilization factor is defined as the ratio of the assumed mobilized or developed shear stress along an assumed slip surface to the maximum shear strength of the soil material at failure. The safety against sliding may be assessed by calculating the average SMF along an assumed sliding surface from an equilibrium analysis and comparing it to a recommended maximum value. These concepts are illustrated in Figure 3.7. In equation form, the strength mobilization factor may be expressed as This application will do all calculations and verifications to establish the width to stem, length of heel and toe, base thickness, key dimensions. Plot the unfactored shear on stem, factored moment on stem. Plot the variation of required reinforcement on tension and compression mode. Plot the nominal moment versus factored moment, tension steel stress on stem, neutral axe position on stem, wall elevation with cutoff location, and finally, the rebar's reinforcement distribution. It can generate a PDF file with all details and information. It is the only application which can generate a DXF file and send it to any email you want.